Hi, my name is Stephen Burns. I'm an applications geophysicist with Geometrics. I'm here today to show you how to use the MagArrow. This is our MagArrow magnetometer. It's our first ever UAS enabled magnetometer. And what that means is that you can connect this to a drone, let's say like a DJI M600 or a 210, really any platform capable of flying and connect and collect magnetic data over a very large area very quickly. Our MagArrow weighs only 1 kilogram, and it's a very unique device in the fact that we've made it extremely simple to operate. This video today will show you how to effortlessly connect to the MagArrow, collect data with the MagArrow, and export that data using a variety of devices, either your laptop, cell phone, or tablet. To start, let's go over the MagArrow. MagArrow is about 1 meter long, a little bit less than that, weighs 1 kilogram, 4 connection points for its tether system, 2 LEDs for a status indication, and then its battery compartment. The magnetometer sensors of the MagArrow are contained here in the butt end of the MagArrow, and they're separated from the electronics by some distance. I don't know, about 1/3 of a meter. That allows it to be free of any magnetic interference from electronics. Likewise, the batteries that we recommend and use, this is 11.1 volt, 2200 milliamp hour RC battery with a 3-cell, it's a 3-cell. This is a non-magnetic battery. They're fairly inexpensive and easy to acquire. The magnetometer sensors that the MagArrow uses is our MFAM sensor. And we have 2 of them within the MagArrow, which basically enable it to collect data anywhere in the world with no dead zones. To turn on your MagArrow, you first need to connect a battery. To do that, we open up the battery compartment. We have the ability to hot swap batteries with the MagArrow. So you can collect data for 2 hours with one battery, and then you can seamlessly transition to another battery, and you can keep doing that as long as you keep charging the batteries, or storage runs out. Most drones nowadays have a flight time of about 30 minutes, so our MagArrow lasts 4 times longer than your drone will. So while the drone is having its batteries changed for your survey, the MagArrow is still collecting data. These are the 2 battery connections. You would use both of them if you're hot swapping. You'd plug the other battery in, unplug this 4-pin connector, and then plug that into the new battery. The MagArrow status page, which is magarrow.net, will tell you the battery life of your MagArrow, the percentage. So to start, we'll plug in the main connection and then also the 4-cell connection. Also in the battery compartment is the power button and the USB stick for firmware. To turn on the MagArrow, you hold the power button, press in, hold it in for a few seconds, and release. It should now flash once every 4 seconds. It's in standby mode. Once I connect to the Wi-Fi network that the MagArrow is broadcasting, then it'll flash twice every 4 seconds. Once I have that and I'm connected to GPS, then it'll flash twice every second. If your MagArrow is encountering any issues and you need to troubleshoot it, it'll flash 5 times every second. So let me package this back up. And then I'll connect to the Wi-Fi network of the MagArrow. The MagArrow, its electronics also has a GPS, a Wi-Fi chip, onboard storage, and together these allow you to collect very high quality magnetic data. The MFAM sensor has a 1000 hertz sample rate, so you can collect data every millisecond. If you're traveling at, one moment, this is the hardest part sometimes. If you're traveling at, let's say, 10 meters a second with your MagArrow at a 1000 hertz sample rate, that means you're collecting data every centimeter. So very high data density with the MagArrow, and the GPS samples at 1 hertz. So every second you'll get a GPS data point, which you can then use to get position and timing data for all your other data points. We recommend that you use the GPS positioning of the drone for your magnetic data. The GPS within the MagArrow has an accuracy of 1 to 3 meters, and therefore is typically not suitable for accurate positioning for high resolution targets. But the GPS on a drone, especially if it's RTK, is very, very accurate and is easily input into data analysis software for very accurate magnetic data processing. You would simply add in your GPS files at their respective timestamps and then interpolate in between. So again, we're flashing once every 4 seconds, which means we're ready to connect to the Wi-Fi network of the MagArrow. The MagArrow puts out an open SSID, which is the Wi-Fi name. In this case, for this MagArrow, it's Green Acres. Every MagArrow has a unique SSID. So let's connect to that. So Green Acres is open. I'll connect. And once connected to the MagArrow, I just go to magarrow.net on whatever device I'm connected to. Now, it's important. The MagArrow can only be connected to one device at a time. If you connect multiple devices to its open Wi-Fi network, you can create problems with the data. It might not start or stop correctly. So, if you are surveying with the MagArrow and there's multiple people in the field, please turn all other devices to airplane mode when operating around the MagArrow. Only one device should connect to the MagArrow. This is also true if other devices have connected in the past. Let's say you've used your cell phone for a survey, but now you're using your laptop. If you have it on connect automatically, both will connect and therefore potentially cause some issues. It's best not to even deal with that and to just always make all devices in airplane mode except the device that you're connecting to the MagArrow. So here's my web browser. I go to www.magarrow.net. And you can see here that we're connected to the MagArrow. If you just type in magarrow.net and you are not connected to the Wi-Fi network of MagArrow, nothing will come up. This is all loaded internally. So we can see that, are we recording? No. But it's running. Here's the field reading. The GPS is unavailable because we're indoors, and the battery's at 95%. Now, if we were to connect to the GPS and we were outside, the MagArrow would flash 2 times every second. So it'd be a double flash every second. That means you have Wi-Fi connection and GPS connection. We can look at our status here as well. Sensor, here's the field readings, the data valid, time since boot. And now we can actually start collecting data. So to collect data with a MagArrow, you need to first create an acquisition or activate a prior acquisition, and then you hit start or stop collecting data. In this example, we will create a new acquisition, in which we have just done. We have now created ACQU2, and it has automatically activated it. If we look here under active, yes, it is active. To collect data on this, all we have to do is hit start collecting data. Okay, active acquisition, ACQU2 is a recording. Yes. If I refresh the browser, we'll see that 286 kilobytes of data have now been collected. An important note, do not refresh your MagArrow browser to see what the data size is if the MagArrow is not right next to you. If you are not at the start before you've attached it to the drone or the end after it's come back, you can cause some issues connecting to the MagArrow if it's flying up above you. So it's best not to entertain the thought of being able to connect to the MagArrow mid-flight via the Wi-Fi chip. If you do this and you find you're unable to connect to the MagArrow once it's landed, of course, you might start worrying that, oh my God, my data, I won't be able to get my data. You would go into airplane mode on your laptop, exit airplane mode, and then you would type in again magarrow.net to connect to the MagArrow. That should solve your problems. But it's best to not do that at all. Again, the MagArrow is designed to be a start and stop operation. So we will refresh the browser again. And now we're at 2,200 kilobytes. I can hit stop collecting data. And now we are no longer recording. If I refresh, we have not gone up. I refresh again, 2,403 kilobytes. If I wanted to resume collecting data, all I do is hit start collecting data. And now we are recording on the MagArrow again. Again, it's very, very simple. Start and stop operations. We'll refresh to see if the data has gone up from 2,400 kilobytes. And now we're at 2,700 kilobytes. So at this point, we can stop collecting data. And we can now download the data. And it'll download right to your device. If you have an iPhone or an Android, it'll download to your phone. Same with the tablet. I like to connect to it with my laptop. It makes it easy to export the data. I don't have to export the data afterwards. So we have our screen here, and it's survey. We could call it MagArrow YouTube video. And it's saved in a proprietary mag data file. That's a raw data file. And to get that into a usable format for Surfer or GeoSoft Oasis Montage or any other analysis program, you have to run this data through our Survey Manager file, of which there is a video. Very, very simple. Hit save. Looks like I already saved one there. There it is. And now we can turn off the MagArrow. To do so, you open up the battery door. And you would hold down the power button for 3 seconds. You go 1, 2, 3. And now your MagArrow is powered down. Unplug the 4-pin connector first, and then unplug the main connector. We touched on it earlier, but to update the firmware, you need to pull out this little USB thumb drive here. And here it is. This is included with every MagArrow. It's a non-magnetic USB stick. Very important that you use the one included with your MagArrow. And what you do is you'd upload the newest firmware to the stick and simply plug it into your MagArrow. Close this back up again. Before we do that, though, I want to show you the suspension system for the MagArrow, and I also want to show you a couple quick best practices for surveying with the MagArrow. This is the suspension system that we've created here at Geometrics. It's very simple. It's basically paracord with vinyl tubing on the outside. So you thread some paracord through this vinyl tubing. It's a nice blend of fluidity and rigidity. We find that the MagArrow stabilizes in flight very quickly, but it's still able to function semi-independently of the drone. We recommend that the MagArrow is spaced about 3 meters from the drone. That way there's no magnetic interference. You can see this cable here. I have a long wingspan. This cable here is still longer. So this is a 3-meter suspension cable. To connect your MagArrow with a suspension system like this, we use zip ties. So a zip tie through the foot. Simply close it up. It's best to snip off the remainder. To connect the zip tie to the drone, you would want to, again, take another zip tie. You'd want to connect around the leg, the arm of the drone. Give it a little bit of slack so you're not damaging the arm when you're cutting it off, so you have room for scissors or a knife. But then use electrical tape to secure it. It's also very important that you snip this off. That way the extra zip tie does not hit the props of the drone. You wouldn't want your drone to crash because of a zip tie. We do not recommend you fly the MagArrow under a drone that does not have an established payload of more than or less than 3 kilograms or so. It is a 1 kilogram payload. It's very light. It's not going to impact the flight time that much for a drone that has a larger payload. It'd be very unfortunate to crash both your drone and a MagArrow. Some quick notes about surveying. The MagArrow, we find, flies very, very well when flown correctly. That makes sense. This is an aerodynamic instrument, and this is the front of the MagArrow, this is the back. This is where the sensors are. It's aerodynamic. It's meant to be flown forward. When you do so, you find the MagArrow stabilizes very quickly and really locks into a steady pattern. If you fly the MagArrow butt end first, what it'll want to do is flip around and fly this way. But now, since there's tension in the suspension system, it will end up just swinging like crazy. Very bad for the data. Those movements can happen 2 ways. First, if your drone is flying forward but then flies backwards, that'll present a problem. So you want to make sure you have a flight software that you use that always flies forward, and that you mount the MagArrow to the drone in such a way that forward of MagArrow is also forward for the drone. The second way to eliminate a lot of problems with MagArrow movement under the drone during surveying is to connect your survey lines with a curved semicircle. So what does that look like? So if you're surveying like this, you're going up, it's a straight line, GPS path. You want to do a semicircle to connect them and then go down again. This will ensure that the MagArrow platform stays as stable as possible because it will swoop through the air like this, turn around, and then go the other direction. If you have a hard 90-degree turn, the platform will move quite a bit. It'll move again, another 90-degree turn, and then it takes about 10 to 15 meters to stabilize in flight. The MagArrow is stable at 5 meters a second, 15 meters a second, 10 meters a second. And how fast it stabilizes out depends on the speed. But typically 10 to 15 meters, if there is any jostling during flight, your MagArrow will be stable. This is important because you need to know where to cut your data. If you want to make sure you only have really high quality, stable data for your data set, then you'd want to cut here, for example. And this is your survey area. If you do not have flight software that allows for curved survey line connections, then you need a smaller survey area. So this is, if that's your survey, you might need to go 15% smaller. It's important to practice, or it's important to put into practice these flight considerations because UAV flight time right now is very limited, typically about 30 minutes. And any increase you can have in data quantity and flight time is very valuable and gives you a competitive advantage. So flying this way will get you, depending on the size of the area, 5 to 15% more data than flying with these hard corners. The flight software that we recommend for this is UgCS. And let's go to that now. If you want to see what UgCS looks like, we'll go to their website. And this is the UgCS flight mission planning software. This software is great because you can import KMLs, you can use satellite imagery, digital elevation maps, you can plan a flight that has elevation and altitude tracking. Basically, it can do anything. And it's software not designed just for photogrammetry, which is most UAV software. It's flight software designed for flight. And therefore, you can use it for geophysical surveys as well, or in our instance, MagArrow surveys. So we recommend UgCS. We do not recommend photogrammetry software for your MagArrow survey. So please, if you are going to survey with the MagArrow, please get the right flight planning software because it's not worth a crash. Here are our partners right there, Juniper and Mand. They are one of the pioneers of UAV magnetometry, and looks like they have a nice quote here on their website. That has been the initial MagArrow setup and operation video. I hope you found this useful. If you liked the video, please leave a thumbs up and write your thoughts in the comments below. You can contact us with more questions via our website, www.geometrics.com. We have multiple contact forms, either for product inquiries or for support. And there's quite a few resources on our MagArrow product page. So if you have further questions, you can look at some FAQs for the MagArrow on the product page. You'll also be able to find this video there. Thank you for your time.